Let me introduce the process of 3D model creation. First, we created 3D models using AI-driven sites or downloaded well-made animal models from Sketchfab. Then we used Blender to modify parts such as arm positions and textures, and implemented movements through Mixamo. This is a site called Genie by Luma AI, which generates 3D models from text inputs. We input cute green fox to create a mascot for Children's Grand Park. Next, we used the CSM site, which converts images to 3D models. We took a picture of the mascot sculpture at Children's Grand Park and generated a 3D model. The quality was surprisingly good, so we used it as the main model. The following is Sketchfab, where we downloaded various 3D models of animals. Next is Blender, where we corrected oddly protruding parts of the AI-generated 3D models. Then we used Mixamo, a site that automatically applies animation movements to 3D models. Although we intended to add various movements to our main model, we omitted some due to unnatural aspects. Now, let's talk about AR service development. We used Three.js, A-Frame.js, and AR.js, which are libraries that utilize WebGL technology. Especially, Three.js has many good tutorials on YouTube, allowing detailed learning from basics to advanced topics. Additionally, the official Three.js documentation is well organized, making it easy for beginners to use. I will explain the details through the code. First, the camera stream setup method. Since the 3D model needs to be overlaid on the camera, we first need to input code to turn on the camera. I use the media devices, getUserMedia, the method. The getUserMedia method is part of the WebRTC, Web Real-Time Communication API, allowing web applications to access user media devices like cameras and microphones. Notably, in CSS, setting z-index 1 is important. This places the video element behind all other elements by using a negative value. Also, in the function part, you can see the use of the media stream object and the .catchMut function error part for error handling. Next, the method for loading 3D models. The details are available in the official Three.js documentation. First, include Three.js and GLTF loader libraries in the HTML file. Then, initialize Three.js and set up the scene, camera, and renderer. Use GLTF loader to load the 3D model and add it to the scene. Let me explain again through my code. Import. As 3 from 3, import. Orbit controls, from. Import GLT floater, from. This code imports the Three.js library and related modules. Using Three.js, I loaded the 3D model and set up orbit controls for user interaction. Next, here is the code for creating a 3D scene. And here is the crucial code for loading the 3D model. As you can see from models main.glb, it accesses the 3D file I have saved. You can then adjust the scale and position. Next is the code for adjusting the lighting. Lighting is important to enhance the realism of the 3D scene and highlight the details of objects. Ambient light illuminates the entire scene evenly, without shadows, providing the same amount of light to all objects. Sexfuff represents the color of the light, which is white. 1.0 represents the intensity of the light. You can adjust this value to control the light's strength. Directional light casts light in a specific direction, similar to sunlight. Next is the code using orbit controls to allow the 3D model to rotate and zoom in/out around the camera. Now, let me explain about animation. The method for animation is also detailed in the official documentation. Using Animation Mixer and Animation Clip, you can control the animation of the model. I will explain in detail through the code. Const Mixer, re-const new 3, animation. Mixer model, GLTF, animations, for each, clip, pass. 3. Animation Mixer is an object that controls the animation of the model, created with the model as the parameter. The GLTF.animations array contains all animation clips, and for each clip, Mixer.clipAction clip is called to create an animation action. Next is the function for playing animations, play animation. Using math.random, it selects a random index, reset the corresponding animation, and then plays Play Pilot. When you press the Play Random Animation button on the elephant model, you can see the stored actions being executed. We added AR animations or rotation animations to over 20 animals. Next, let me explain about A-Frame. Using A-Frame and AR.js, I implemented an augmented reality scene in a web browser. I referred to the AR.js official documentation. The following code imports the AR.js and A-Frame.js libraries. The code sets the scene to embedded mode for use with other HTML content. AR.js, source type, webcam. This AR.js setting uses the webcam as the AR source. This defines the AR marker. Preset.hyro uses the predefined hyro marker. GLTF model.models main GLB. This loads the GLTF model file and applies it to the entity. As we saw earlier, the code adjusts the lighting to make the model more visible. Therefore, visiting the web page with this code applied and scanning the hyro pattern will display the model as shown.